Today we will discuss how to calculate the physical address of an item in the Intel 8086 architecture. Let us start. For example, we have this problem. Calculate the physical address of the input data which is stored on address 2E2C hexadecimal, and the segment registers have the following values. The code segment register has the value 3522 hexadecimal. The data segment register has the value 1E2C. The stack segment register has the value 332B, and the extra segment register has the value 1114. All are in hexadecimal format. So how do we solve this problem? Okay, so first we have to know what is the formula in calculating for the physical address. So let us look at the formula. The physical address is calculated according to this. So we need to know first the offset or the logical address of that item. And we need to know also the segment address. It means where does that item reside in the memory? What segment in the memory? So we have to know the address of that segment. So that segment will be padded with 4 binary digits zeros, after which we add these two values, and the sum will now be our physical address, the actual address in the memory. So please take note, we have to know these two, the offset of that item or the logical address of that item, and the address of that memory segment where that item resides. Okay, so just to recap, so there are 4 segments inside the memory: the code segment where instructions reside, the data segment where operands or data reside. We have the extra segment where user-defined data or operands reside, and we have the stack segment where programs reside. So we have to know where from these memory segments our item resides. And we have these registers in our Intel 8086 architecture that hold the addresses of these memory segments. So we have the code segment register, which holds the starting address of the code segment in the memory. We have the data segment register, which holds the address or the starting address of the data segment of the memory. The extra segment register, which holds the starting address of the extra segment of the memory, and the stack segment register, which holds the starting address of the stack segment of the memory. So we have to know where our item resides in the memory, and this is our formula to calculate for the physical address. So if we know the segment where it resides, so we will know the segment address. We multiply it with 10 hexadecimal in order to add the 4 zeros at the end, no? The binary zeros. And we add the offset address of the item, meaning the logical address of the item. So going back to our example, to our sample problem, so we have to identify what is the offset and what is the segment address. So the given here, because it is stated in the problem that the input data is stored on address 2E2C, so this is our logical address. This is the offset address of the data. So now since this is a data or an input data, all the data or operands reside in the data segment in the memory, okay? The data segment portion of the memory. Therefore, we know that the data segment of the memory, the address, the starting address of that is stored in the data segment register. So therefore, we already know now the segment address. So this is what we will use. So therefore, we now have, so our 2E2C is our offset and our segment address is 1E2C. Okay, so from the problem, these are the values that we will be using. So offset is this value and the segment address is this. So the formula now, segment address multiplied by 10 hexa plus the offset. So we just substitute these values into our formula. So giving us now segment address is 1E2C, okay, and then we multiply it with 10 plus the offset, which is 2E2C. So we just do the math. So this one will be evaluated first. So 1E2C multiplied by 10 will give us 1E2C 0. So that result, we now add the 2E2C, the offset, giving us now the value. So 1E2C0 plus 2E2C hexadecimal addition, it will give us 210EC. So this is now the actual or the physical address of the input data. All right. So thank you for listening. Enjoy.